Hello dear student, welcome back to Jihan College Online School. Today our subject is about magnetism. My name is Khalat Kamiran. This lecture is for grade 7. From the science book, it starts from page 278 till page 291. We're starting by atoms and domain. All matter is made of atoms. Electrons are negatively charged particles on atoms that they have south and north poles. Domain are like tiny magnets of different sizes within an object. So we already know that, like we talked about or explained it before, each magnet has two poles. One of them, its directions to the south, so we call south pole, and the other one, its direction to the north, so we call it by North Pole. Also, both poles, which means south and north, are lining up and making a strong magnetic field. So we have this picture. The domain over here, it's directions from everywhere, so it's not lining up, it's not organized. So we called unmagnetized matter. But if the domain was like this Q, or lining up, or all of it to one direction, so it has magnetic properties. Losing alignment and making magnets. Domain won't always line up. Sometimes it will be moved. When it moves, it will be unmagnetized. Higher temperatures make atoms vibrating more, which causes losing magnetic properties. How we can make a magnet? If you bring a pin, then we rub it with a floor or anything else. Just we have to be careful that we have to rub it by one direction. Okay, so this fraction give the pin a magnet's properties, but its properties is not permanent, it's temporary. So all the domain or all atoms from the pin, it will get one direction, so it gets the magnetic properties. This clip is holding with a pin. The pin is holding this clip because of it gets the magnetic properties. Types of magnets. We have two types of magnets, temporary and permanent. Temporary is easily to magnetize, like soft iron. The permanent one, difficult to magnetize, like alnico and alloy of iron. Also, we have Earth as a magnet. We have geographic poles, and we have magnetic poles. The geographic poles, it's like a straight line, okay? The world is rotate around it. The Earth is rotate around it, but the magnetic one, it has a slope like this. The red line is magnetic pole. So the magnetic field line around Earth are similar to the magnetic field lines around a bar magnet. So it's the same. You see, it's the same. Also, one more information. If we bring a magnetic, Okay, we put it like we want. Okay, the south pole of real magnetic that we have its direction to the north pole of magnetic poles from the earth, and the other one inverse it, so they are inverse to each other. Electromagnetism is the interaction between electricity and magnetism. Solenoid, a coil of wire with an electric current in it. Electromagnet is made up of solenoid warped around an iron core. So this is we can call by solenoid because there's a wire or coil, okay, and also the electric current inside it. So this is solenoid. Doorbell and galvanometer. Doorbell's magnetic field is produced from electric current passing through the bell solenoid, which is controlled by a circuit. You see in here, this is solenoid, okay? Inside it, this is an iron that we talk about now, and this is the circuit. This is the solenoid and this is the iron. When we close it, this circuit, then the electric current is going to be passing inside the coil, so by force the iron is going to be moved, so it's heat or crushing the bell. What's the galvanometer? Is a device that measures a current. This is galvanometer. Electric motor is a device that changes electric energy to mechanical energy. So this is electric motor. This is a loop or a wire, okay, which called armature. Each side is connected with one pulse of the magnetism. When we close the circuit, okay, the electric currents pass through the loop, and the magnetic is making a force which is caused the rotation of the coil or pole. Or transformer is a device that increase or decrease voltage of alternating current. Okay. Each of them are a different voltage. How? Now we have step up. Okay. Step up transformer. So we have two types of transformers, step up and step down. Step up has fewer loops than the secondary coil in a primary one. So in here we can call this one by step up transformer because the coil of primary coil is less than the secondary coil. So the voltage of the electric current in secondary coil is higher than the voltage of the electric current in primary coil. But in here this is step down. Why? Because the primary coil is more than the secondary coil. So the voltage over here is higher than the voltage of secondary one. So this is the step down. How we can get electricity in our home? So this is the generating station, high voltage, okay? They're using the step up transformer because this is the voltage over here is very high. So this step up transformer make it down. How? The coil over here from the primary one is less than the secondary one. So the voltage from the secondary one is higher than the primary. Okay, then by wire it's going to be transporting for higher voltage. Then we have distribution station, which is this is step down. Why? Because the coil from the primary one is more than the secondary one, so the voltage is lower than from the primary is lower than the voltage of secondary one. And this is local power distribution wire, which is less than voltage. Then it's going to the house. This is how we can get electricity from our home. Thank you for listening. I hope you enjoy with me.